two sorted linked lists. Merge them into one sorted list. The nodes must stay. You splice the existing ones into a new chain. What's your move? List 1 goes 1, 2, 4. List 2 goes 1, 3, 4. The merged answer should read 1, 1, 2, 3, 4, 4. 2 lists in, 1 list out, still sorted. A linked list is a treasure hunt. Each node holds a value and a pointer to the next clue. To reach the 4, you walk from 1 to 2 to 4. We're not building new nodes. We rewire the existing ones, pointing them at each other in a new order. The output is the same nodes, restitched into one chain. And both inputs already arrive sorted. That property is the whole game. We never have to look ahead, never have to look back. Look at the two heads. Both are 1. The smaller of the two heads is the smallest value across both lists, so it goes first into the merged chain. They're tied, so pick either. Take list 1's 1, snap it onto the output chain, advance list 1's pointer forward to 2. List 2 stays put. Compare the new heads. 2 on the left, 1 on the right. 1 is smaller, so it goes next. Hook it onto the chain. Advance list 2's pointer to 3. That's the entire loop. Smaller head wins. Hook it onto the tail of the output. The list it came from steps forward. 1 comparison per step, forever. Remember, add 2 numbers, 2 pointers, walking both lists in lockstep, processing 1 column at a time. Same dance here. Pointers walk. You take what you need at each step. Watch the very first node. Which list does the merged head come from? You don't know until you compare. Trick. A fake dummy node out front. Build off it. At the end, return its next pointer. And when one list runs dry, the other one's tail is already sorted, by definition. Don't loop through it. Just attach it to the merged chain in one step. Start fresh. Dummy node with a tail pointer parked on it. List 1's head sits at 1. List 2's head sits at 1. The output chain is currently empty. Heads tied at 1. Take list 1's 1. Tail's next points to it. List 1's head advances to 2. Tail moves forward to the node we just placed. New compare. 2 versus 1. 1 is smaller, so we take list 2's 1. List 2's head advances to 3. Tail moves forward again. Compare 2 and 3. 2 wins this time. Take list 1's 2 onto the chain. List 1's head advances to 4. Compare 4 and 3. 3 wins. Take list 2's 3. List 2's head advances to 4. Both heads are now 4. Tied at 4. Take list 1's 4. List 1's head advances to null. List 1 is exhausted. The loop condition will fail on the next check. List 1 is empty. List 2 still has a 4 sitting there. Attach that remainder to the tail in one move. The merged chain reads 1, 1, 2, 4, 4. Notice what happened. Every node was touched exactly once. No copies, no second passes, no backtracking. The sorted property meant 1 comparison per step was always enough. Time grows with the total node count. M plus n, each touched once. Space is constant, just the dummy and the tail pointer. The output reuses the existing nodes. Time for the code. Same names we used in the trace, dummy, tail, list 1, list 2, so the algorithm reads the way it sounded. Create a dummy list node. Park a tail pointer on it. The dummy is the fake head we build off. We'll skip past it at the very end. Loop while both lists still have nodes. If list 1's head is less than or equal to list 2's, splice list 1's node in and advance list 1. Otherwise, splice list 2's. Either way, the tail moves forward. Once the loop exits, exactly one list is empty. Attach whatever's left of the other directly to the tail. It's already sorted, so no extra work. Hand back dummies next. That's the real first node of the merged list, skipping the fake one we started with. Dummy head, 2 pointers, splice. You'll reach for this pattern every time 2 sorted things need to merge into one.